let's start with the question, find the power of k size subarrays 1. If you have not gone through this problem before, I would highly recommend you to try it yourself first, then come back to the video. Okay, now let's start with the solution part. What they have given, they want us to visit each and every subarray and check whether the subarray is in increasing order. If subarray is in increasing order, as we can see here, 1, 2, 3, subarray is in the increasing order, we are supposed to return the highest element in that subarray. And subarray size is 3, so that's why I have taken all the subarrays of this array of size 3. Okay, now let's start with the first subarray that is of size 3, that is 1, 2, 3. If you see, this subarray is in the increasing order, so I can say the answer is 3 for it, right? So let me write it. If you see here, answer is 3. Okay, fine. Now let's consider this subarray 2, 3, 4. Highest element is 4. I'm considering that as the answer because this is in the increasing order. Now let's consider 3, 4, 3. This is the another subarray, right? Now, 3, 4, 3, this is not in the increasing order. What they wanted us to do? They wanted us to return -1 if the subarray is not in the increasing order. So answer becomes -1. Same goes for this subarray. Answer is -1 because it is not in the increasing order. So does this, right? This is also not in the increasing order. Fine. Now let's think about the brute force approach. How we will solve this problem? Look, what they want us to visit each and every subarray. How you can do that? From each index, we can generate subarray, right? That's what I have done here. So from 1, I will visit next 3 elements and I will check whether it is in the increasing order. That's what I did here. Next, once this is complete, I will start from this index and I will generate a subarray and I will check whether it is in the increasing order or not. If it is in the increasing order, I will record the highest element. Same goes for the next index. I will record the subarray starting from that index, which is of size 3, and I will check whether it is in the increasing order. Since it is not in the increasing order, I will record -1 as the answer. Okay, so this way, if we follow this way, how much time it will take? Let's speak about the time complexity. We are iterating each and every element in the array. If we consider array size as n, I will say n times k. Why? Because in each index we tried generating k subarray of size k, right? That's why k is the length we will be iterating again after selecting the index, and this is the time complexity. If we talk about space complexity, to record this answer, we are going to use one array that is of size n. So I would say spaces of n, and others are simple constant space variables. So average, I would say n is the space complexity for the brute force approach. Can we do better? This is, of course, going to take n cross k. I feel we can do better. How? Let's see. I have taken the array in this format. Let's start. What they want us to do, they want us to visit each and every subarray which is in the increasing order. Earlier, I started from here. I checked next k-1 elements whether it is in the increasing order or not. But we are repeating. If you notice, we started from here. We checked whether this sequence is in the increasing order. Okay. Once that is done, we started from here again. And again, we are checking whether the sequence is in the increasing order. If you notice one thing, we are revisiting the index again and again. Suppose k is of length 5, 1, 2, 3, 4, 5. Say I checked the sequence, whether this sequence is in the increasing order. Yes, initially I checked. Now, when it comes to this index, I'm checking this sequence again, which is unnecessary, right? We just wanted to check whether the additional elements are in the increasing order or not. We are repeating this thing here. This is what we can try to eliminate to improve the efficiency, right? So just by looking, you can say that this is going to use two-pointer approach, right? If you see, to prevent revisiting of the array elements, we can maintain 2 pointers. I would say, okay, let's say left pointer is there, right pointer is there. We'll record it. Initially, left pointer is here, right pointer is here. Okay. First, Since this is the first element, nothing will happen. There is no need to compare whether it is in the increasing order or not, since the size is only one. Now, in the initial approach, what will happen? Left is 0, right is 0, right? It is in the 0th index. Anyway, no need to compare. Mind this k is 3, right? Remember that part. We want to generate size subarray of size 3, right? Let's move the right pointer by 1. Okay, right pointer is here now. Check whether 2 is greater than 1. Yes, it is. So this is satisfying our condition. And remember, till now we saw only 2 elements in the subarray, but we want 3. So I will increment the right pointer by 1. Right will come here. Now, when I'm in this place, I will check whether 3 is greater than 2. Yes, 3 is greater than 2. Fine. But if you see the size is now 3. This is what we wanted, right? If you see, this is the size we wanted. Now, if we are able to find a subarray of size 3, which is in the increasing order, what they wanted us to do? They wanted us to record the highest element. Highest element is 3. Okay, fine. Next, we wanted to we wanted to eliminate the revisiting part, right? So what we can do, earlier left pointer was here, right reached till here, right? This was maintaining size of 3. This is the window. Now, since this part is done computing, what we will do, we will increase the left pointer by 1 because now we want to deal with the next subarray, this next 3, right? So we will increment the left pointer by 1 and right pointer by 1. Now left is here, right is here. Okay. Now check whether right element here. 4 is greater than 3. Yes, 4 is greater than 3. And the size is anyway 3. So we will record the highest answer, highest element here, that is 4. Fine. Next, again, start moving the left pointer and right pointer by 1. Now left is here, right is here. Now observe carefully what is happening now. I will check whether this right is greater than the previous element, 4. This is not. So if I generate a subarray 343, this is not in the increasing order. I got to know here itself, right? I will say answer is -1. This is not. Okay, now what is the next move? Earlier we used to increment left and right both. But since this is the element which is breaking the ascending order sequence, we don't want to do that. We want to eliminate this array element, right? So if I try to generate next subarray 4, 3, 2, 3 is involved in this sequence. So anyway, this sequence won't be in the increasing order, right? So what I can do, I can keep on incrementing the left pointer until I reach here and say I started from this place, right? Answer is -1. I recorded it. I will increment the left by 1. I didn't reach right yet. And if you see, left is here, the sequence is having 3 and it is not in the increasing order. So I will return -1 as the answer and I will increment the left again. Now left and right both are coinciding, both are same. Now, if you observe, this was the same scenario when we started, right? When we started, this was the same condition. Okay. Now we don't have any subarray of size 3. Now subarray is nothing. We don't have any element. Okay, then no problem. Let's start from the beginning. Left and right both are in the same place. Anyway, only one element is there. There is no need to compare. Let's increment the right pointer by 1. Check whether it is in the increasing order. No, 2 is not greater than 3. So this is also an element which is going to break the ascending order sequence. What I told already earlier, we will keep recording the answer -1 and incrementing the left pointer until we reach left. Until we reach right pointer, right? So I kept recording -1 until I reached right pointer. Fine. Now again, both the R and L are same. But before continuing, just check from this element, if I start from this element, can I generate a subarray of size 3? No, because only one element is left now. Even if I try to create a subarray, it will be of size 2, not 3. So we can stop our iteration here. And this is the answer we can return. Okay. I hope this approach is clear. Now, if you talk about the time complexity, what is the time complexity for this? Max, we are visiting each and every element of the array, and we are not repeating this visit, which we used to do earlier. So this is big O of n. Space complexity, if we consider the size of the array to store the answer, that will be big O of n. So this is the complexity, space complexity. Hope this is clear. Now let's go to the code part. Okay. Initially, this is the size of the array I recorded. Fine. These are the left and right pointers. And this is the answer vector where I will be storing my answer. Fine. Now I have created a separate variable moves and I have assigned it as k. What does this mean? This shows us that how many elements we are supposed to keep in our subarray to match this. I will, while dry running the code, I will explain how this exactly works. Okay. For now, ignore this condition. Okay, let's start. Initially, left and right both were at the 0th position, right? This condition is going to pass and we will come inside this loop, while loop. Okay. Left and right both are 0. That's why this condition will succeed. What we'll be doing, we will be incrementing the right pointer by 1. That's what we did here. When left and right both were equal, okay, we will consider that element in our subarray and we will increment the right, right? Same thing we did. So I'm considering the array element. That's why how many more elements I need to keep in my subarray? Just 1 minus the remaining element, right? That's why I'm decrementing it by 1. Now say 3 is the subarray we need to fill. Since I'm considering this 0th index, how many more elements we need? We need 2 elements. That's why I'm subtracting it by 1. Okay, fine. I have incremented r by 1. Okay. Next, what will happen? Now L is 0, R is 1. I will come to this place. Now I'm checking whether, okay, one more thing. What they wanted us, question, if you read it, they asked us to follow ascending order as well as the consecutive thing, right? If if I consider this subarray, this is in the ascending order and the elements are in the consecutive manner, right? If you subtract this and this, the answer will be 1. So this element is in consecutive order, right? So that's what, instead of that, I'm checking like current element and the previous element, whether the difference is 1 or not. If the difference is 1, that means it is a consecutive element. Okay, that's fine. Next, if the element is in the increasing order and it is consecutive, I can consider that element and I will add that in my subarray. That's why I'm reducing the moves and I'm incrementing the right pointer. Okay, fine. This will keep on running until either I reach the end of the array or my subarray is full of size k, right? Now, let's see what is this if and else block doing. See, I have written moves is not equals to -1. Moves will be -1 only when we are done filling our subarray, right? But here moves is not 0. That means somewhere in the middle, we notice that, I mean, here if moves is not 0, that means somewhere in the middle, we found out an element which is breaking the ascending order sequence or which is breaking this consecutive order sequence. That's why in the middle we broke this loop and we came out. Okay, in that scenario, what I told earlier, say this is the sequence. Initially, 3 was the one, right, which was breaking the sequence, and left was here. I told to increment the left pointer and record the answer as -1 until we reach the right pointer, right? So that's what we did. I wrote a while loop until left reaches right. I'm pushing the answer as -1 and I'm incrementing. Okay, this sequence, you remember what I did in the end. We reached here and we checked whether we are capable to generate next 3 elements. No, we are not capable. That's what this condition is checking. If we are not capable to generate next k element, then break out. Otherwise, keep continuing. Okay. Now, till we reach right pointer, we used to increment left. Okay. Once that is complete, I told we will be starting from fresh because we don't have any element in our subarray now. We'll be starting from the beginning. That means left and right both are in the same place. We will start adding the elements from now on. And if you see, I have assigned k as the moves because from now we will be starting from the beginning, right? We don't have any element in the subarray. Okay, this condition will continue. Now, when the move is 0, that means we are successfully filled the subarray, which is in the increasing order, and it is a consecutive. Then what we'll do, we'll record the highest element in that sequence. We will increase the left pointer. Right pointer, it will increase because anyway, this condition, if you drive it properly, you will get to know right pointer will be pointing here initially. If you see, left will be here, right will be here. In the code I'm comparing this with the previous one. You will get to know once you start coding it. And moves, okay, moves I have assigned it as 1. Why? If you see this, initially left was here, right was here, right? The sequence is completed. Then I decided to move left pointer by 1 and right pointer by 1. Now I eliminated one element. That is, we are short of one element in our subsequence, right? Subarray, not sequence. Say, I will write it down here. 1, 2, 3, 4. Initially, we considered this much. Size is 3, right? When I am moving my left pointer by 1, size of my subarray becomes 2. We can fill one more element, right? That's what the capacity I am returning here in the code. If you see, moves is 1. Now, again, this condition will follow up. And this is the breakpoint. One first thing, whether R is less than the size of the array. Second thing is, are we capable to generate a subarray of size k? This is the condition. And we are returning answer. Thank you.